Good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is Hamper Kliman. And today we shall be doing composite functions. What is a composite function? A composite function is simply a function in a function. And of course, you'll be asked different questions concerning how you should find questions under this particular topic. And oftentimes you'll be asked to find the domain and the range. So in this particular question, the first question is simply saying, find the domain of the following composite functions. Let's start with the first one. So for A, we have been taught that we find the domain of some function f plus some g being evaluated at some point x. Now, what we're going to do here is simply to add these two particular functions. So the function of f of x is simply x plus 2 plus the function g of x is simply the radical of x plus 5. Now, one thing that you must understand under this topic is that all polynomial functions have a domain from negative infinity up to the point positive infinity. So whenever you find a function in this particular order, okay, in this particular order, let's say x plus 2, or let me just say the function in this particular order we have ax squared plus bx plus c. This function has the domain from negative infinity all the way to positive infinity. We call it a quadratic equation or quadratic function. So in this case, this particular part is a quadratic function. Therefore, its domain is going to come from all the way negative infinity to positive infinity. How is it able to hold? We are able to see that this is a quadratic function, and whatsoever value, whether positive or negative, that we put on x is going to hold. Let's try to solve for this particular part. Well, we know that if we put, let's say, negative 6 where there is x, and we put it in this function, this is not going to hold. Therefore, for radicals, we treat them differently. So in this case, we have x plus 5. So we get the x plus 5. Then we say let it become greater than or equal to 0. Then this is going to be x greater than or equal to 0. Then we have negative 5. So in other words, the only value which is going to hold in this particular radical should be greater than 5. So for this particular radical, the domain is going to come all the way from negative 5 included all the way to some point positive infinity. So now how do we combine the range? How are we going to combine the range? So in this case, we have been told that it's going to come from negative infinity all the way to positive infinity, but we have a negative 5 and then we say 0. Okay, so for this particular one, let me just use a different color. For this particular one, okay, for this particular one, we have the first one, which is coming all the way from negative infinity going all the way to positive infinity. But for the second one, let me just use a different color. I can use particularly green. Look at this. It's coming from negative 5 with a closed circle, which means it's included all the way to positive infinity where we have an open circle like this. So where these are meeting, that is where the domain is. So in this case, the domain is coming all the way from negative 5 included all the way to positive infinity with that bracket. This is our domain. It's actually simple. All right, let's do the second question. Let me just try to wrap the board. Okay. The second question is simply saying f of x is equal to x plus 3 and g of x, x plus 2. And then we're told to find the function of f of g being evaluated at some point x. So in this case, what we do, we are going to get the function of f, which is x plus 3, and then we have x plus 2. Whenever you have a function of this kind, where you have a ratio, the only thing you have to concentrate on is the denominator, because you don't need a value which is going to make the denominator undefined. And of course, how do we know the number which is going to undefine the function? We simply equate the denominator to 0. Okay, so we are going to say that x plus 2 must not equal 0. Okay, that's what we do. And then we say that x must not equal negative 2. And this is true because if we put negative 2 where there is x, this is going to be 0, and anything of this particular function will undefine the function, so we don't need that. That is what we're avoiding. So this is x plus 2. So upon finding this, the domain is already found. How do you find the domain? The domain for this particular function, we have, you can use this parameter, negative infinity, positive infinity. We have negative 2. For the first one, it's going to go all the way to, the first one is going to go all the way. It will come from here with an open circle. It will go up to negative 2. At negative 2, it's going to have an open circle, meaning negative 2 won't be included, because if we include it, it's going to undefine the function. Then it will proceed all the way to positive infinity. Okay, so in this case, we can find what we want. It becomes easy. So we have this domain here, then we have this domain from here to there. So therefore the domain for this particular function is going to come from negative infinity going to some point 2 with these brackets, the union of negative 2 all the way to positive infinity. So this is just how you solve this particular question. If you find this video interesting, consider subscribing and also hitting the like button. Thank you so much.